So we want to graph this piecewise function. And this piecewise function has three pieces. So let's take a look at our first piece. Our first piece is the function y is equal to negative x squared plus 3. So if you haven't put in a lot of time practicing transformations yet, graphing the individual pieces may be complicated. That may be something that you want to do on a separate sheet of paper if you feel like you need to do all the individual steps. But as you practice more and more transformations, you'll become more efficient in graphing them, and hopefully you won't have to do the parent function and all of the intermediate steps to get to your final answer. So for example, on this one, I hope that you know it's a parabola for the parent function, y equals x squared. And then because of our multiplication by -1, it's been reflected over the x-axis, but it's also been shifted up 3. So I'm going to go ahead and graph my final answer here. If I shift up 3, my vertex for this parabola is at 0, 3. And then this parabola opens down, and there hasn't been a stretch or a compression of any kind. So from that vertex, we should go left 1, down 1, and right 1, down 1. And then from the vertex, right 2, down 4, left 2, down 4. And it looks like we have room to continue right 3, and then down 9, because that would be 3 squared. So I'm graphing this parabola in its entirety, and then I'll come back with my eraser and I'll erase the portion of the graph that we don't want and decide what we do want to keep. So here's the entire parabola, which is the first piece. So we've graphed this parabola. Now we want to move on to erasing the portion we don't need. So we want the portion where x is less than or equal to -1. So I'll do this in red. So I'll go to x equals -1 and go to my graph. That would be this coordinate here, -1, comma, +2. And I want to keep everything that is less than -1, x values less than -1, which means I would want to keep the left-hand piece, because that's where the x values will be less than -1, and I'll want to erase the right-hand piece, everything to the right of x equals -1. So that's the piece of this parabola that I'm going to keep. And then because I want to be less than or equal to, right here, less than or equal to, it is appropriate to have a solid dot here at x equals -1. Good, so now let's move on to the second piece. My second piece is y equals x plus 1. So y equals x plus 1 is a line. It has a line with a y-intercept of +1 and a slope of +1. So from my y-intercept, I'll go ahead and travel up 1 and right 1 a few times, as well as down 1 and left 1 a few times. So this would be my entire line, the line y equals x plus 1. But now let's move on to the domain, what I want to keep. I'm interested in keeping the piece of the line right here where the x values are in between -1 and +1. That's how this inequality is read. From left to right, it would read -1 is less than x is less than or equal to 1. That really means that x needs to be any value in between -1 and +1. So again, I'll go to x equals -1 on my line, and I want to keep everything from x equals -1 to x equals +1, meaning I want to keep this middle section of the line, and then I will erase everything that is to the right of x equals +1 and everything to the left of x equals -1. So I'm just keeping that middle piece of the line. But you'll notice for the inequalities, I want x to be less than or equal to +1. So I would want a solid dot where x is equal to +1 on the right-hand side. But therefore, on the other side, if you look at it, I don't want to include -1, so I would need an open dot then on the left side of that little line. So there's our second piece. And finally, we move on to our third piece. Y equals 2 times the square root of x. 2 times the square root of x. So for this, again, you might want to be on scratch paper to think about what this looks like. if you were to take a look at a little sketch right here of the parent function, if I were to look at just y equals the square root of x, I know square root of 0 is 0, square root of 1 is 1, square root of 2 is a decimal, square root of 3 is a decimal, but if I come over to square root of 4, I know that is a nice exact value of 2. So we have half of this sideways parabola for the parent function. But then since I'm multiplying the parent function by 2, that means my y values are all going to get multiplied by 2 as well. So at 0, it doesn't change because 0 times 2 is still 0. But this next value, the y value is 1. 1 times 2 becomes 2. And at my second value, the y value is 2. 2 times 2 is 4. So it has that vertical stretch happening because of that multiplication by positive 2. So now let me duplicate that on my graph here. We see we have 0, 0. Try again. Sorry, here we go. 0, 0. And then my next coordinate here was right 1 up 2. And then we had 4, 4 on the stretched graph. So this would be the entire graph of the square root, 2 times the square root of x. And then finally we go to this last portion, the last domain restriction, is we want x values that are greater than 1. So let me go back over this. When x is equal to 1, that puts me right here on the graph. Incidentally, that overlaps the second piece, the line, and that's okay. And we want to keep all the values greater than 1, so I would keep everything to the right, and I will be erasing the left. So this little tiny piece of the... see if I can get that erased for you. There we go. We erased that little tiny piece of that square root function. So the second piece, which is the line, actually connects with the radical function. And not to worry, you might be looking at the inequality symbol here and noticing that x had to be greater than 1, which would be an open dot. But since it was a closed dot before, think of it like the open dot just gets filled with the closed dot. So it stays closed in the end. We have some overlap there. And that's what the graph of this piecewise function would look like.